Good morning all. I am Dr. Dipanwita Debnath, Assistant Professor in the Department of CSE AIML at B.B. Raju Institute of Technology, Narsapur. Today I am going to give the introduction to natural language processing, a lecture from the NLP series. I have organized my contents as Introduction to Natural Language Processing, History to NLP, Core Concepts in NLP, Key Terminologies that are being used in NLP, then machine learning and popular NLP libraries and tools. We will be also discussing the application of NLP, and finally we will conclude this session. So, introduction to NLP. Natural language processing is a multidisciplinary idea to study that integrates computer science, artificial intelligence and linguistics to facilitate effective communication between human and computer using natural languages. We human beings, we basically talk in either spoken languages, written languages or written languages, that is in the text form or in voice or sometimes in the sign languages. At the same time, when we use machines like computers and robots, we want nowadays to these computers or robots or phones to interact with us manually. But how to interact for them or to understand that computer must understand what we are saying or what we are writing. At the same time, they have to respond in a way that we understand the same. So how our machine will be going to do that using the natural languages that we are discussing in this session. So to answer that how machine will be interacting through our human languages, that is natural languages, introduce this subject that is called natural language processing. NLP brings together linguistic, computer science and AI and ML. Linguistic means the study of how our human languages are. That is when, suppose we are taking about the language English or Bengali or Telugu, then every language has its separate grammar, syntax and semantics, or word structures, word forms, even sounds, how we spoke them, that are different from language to language. Computer science means it is computer science, basically we are having the algorithm or computational models that processes different languages or different programs. These are basically the programs that we do to interact with the computers, etc. AI and machine learning, we learn the pattern for the natural languages using the AI and ML. What we do is we learn the pattern from the text or the speech, and then we use that for making the predictions or for decision taking. NLP is crucial in various language applications now. For example, we are working with chatbot, or we are working with text summarization, or we are working with IoT based system nowadays. Then for chatbot, we want our system to respond to our queries or our talks. For example, I'm saying today, I'm not feeling good today. Then our chatbot supposed to respond like, oh, hi, I'm there, or what you want, so that it can understand what our concepts, and so that it can respond our communications accordingly. Same way, when we are in a room, suppose, and our room is equipped with the smart, it is a smart home, or it is equipped with the IoT systems. Before we used to say directly like switch off the machine or switch on the machine. Nowadays, what do we want? We want it should understand us like a human being. Suppose I'm saying someone, it is too cold here. So that person should understand that, okay, this room is too cool and the temperature is so low in this room. So it should like increase the AC temperature. Same way, we want our machines to understand nowadays. So how this machine will understand these natural languages? Because when we are talking about natural languages, it is a very vast or high in nature. So many words are there which meanings are similar, as well as there are many words which has different meanings in different context. For example, we are talking a word, if we take a word bank, then bank may be a river bank may be a blood bank or a money bank. At the same time, if we take a word, for example, apple, then apple can be a fruit as well as apple can be a company. So how our computer will understand, or our language, our algorithm will understand that which context we are taking this apple now, that we have to learn, as well as we have to execute through our programs. So this is the thing that our NLP this course handles, as well as this course teaches us. So as we understood that the day by day, the way we are becoming smarter and smarter, that is in terms of technology, we want our system or every apps to work in our natural languages, the way we are talking or writing or speaking. So there are several applications to this that we will discuss at the end of this slide, that is application to different applications of NLP. So for now, we are this NLP, we are like how this NLP works. It works on the basis of any linguistic. There comes another difference now. For example, our machine, our computer, that understands only the machine language, that is in binary. But natural languages are obviously not in binary. Even our high languages, suppose C programming and all, these languages are basically structured languages. That means, for example, C language, we have 32 keyword, or the words or the syntax that we use that are restricted or in a limited in number. But when we are talking about any natural language, for example English, how many words are there? There are infinite number of words. Even new, every day we are coming with new words. So when we are working with a structured language, it is very easy compared to our natural languages. But as in this era, we want our natural languages more. So this is an important ongoing research area. The history of NLP. In 1950, that is during the Second World War, the person Alan Turing, that great scientist, he was a important person of during the Second World War. And after that, our computer system's backbone, or the main theory behind the computer system, that we call as theory of automata, or the main machine, that is called Turing machine, that works as our human machine, that was been introduced during the after the Second World War by Alan Turing, and that lays any of the machine intelligence or fundamental course for our any of the computer science system. The early NLP research focused on mainly machine translation. Machine translation means, so for example, we are translating some of the sentences from English to Hindi or English to Telugu, like that. That is means machine translation means translating from one language to another. The important use of this one is if I don't know Telugu, then I can convert my text of English to Telugu. So after that, in 1916, rule-based NLP systems were been developed, which are mostly used using grammar rules or dictionaries. In 1966, ELIZA, that is the first chatbot, was came into picture, which is a kind of human-computer interaction. The ELIZA mostly are rule-based, means if-else kind of structure. Suppose it can answer many of the questions that based on a particular product or any usage. For example, a customer service system for Amazon that has been developed with ELIZA, then it must be for any of the particular product of any Amazon product. For example, a iPhone, we want to interact how it is good or how it will be operating. So that kind of system was been made in the ELIZA. In 1970s, we mostly now from the rule-based system, we are now focusing on the syntax, semantics, or linguistic theories. And in 1980s, shift was towards the statistical NLP. The SMT, etc., are been born during this model. The time a probabilistic model or N-gram model or HMM was been introduced during this session. N-gram models are for example, when we are talking to a particular grams, that is unigram. Unigram is basically each of the word. When we are having a sentence, suppose I am saying I am good, then unigram will be containing only the 3 words, that is I am good. So how many unigrams are there? We have 3 unigram, I am and good. But when we are talking about bigram, then it will be combining 2 words at each time, that is I am and am good. So number of bigram in the sentence will be 2, as well as trigram. If we are taking, that is number of 3 words combination, that is I am good, only 1. And more number of grams sometimes gives more accuracy in comparison of the sentences, etc. In 1990s, once the machine learning algorithms are more in picture. Like that time multi-layer perceptrons was been born, was been initiated. That time machine learning techniques are been started using for natural language processing. Suppose a post tagging was been done using the machine learning techniques, or the speech recognition that was been used using multi-layer perceptron networks. In POS tagging, part of sentence tagging, we basically, for suppose English grammar, we have part of sentences like noun, pronoun, verb, adverb. So for each sentences, how, suppose any noun, how will be tagging this as a noun? That is, there are some algorithms that will use some of the popular algorithms like Porter, Stemmer, etc. were been used. In 2000, when 2000, the era of 2000 started, in real life also, or the wave use of wave was more and more that day. So basically now, previously we was having limited data and we used to mostly work with the databases. In 2000 mostly the data analytic part started, or companies or online services was increased by that time, or more use of smartphone or webs are started in real. So that time corpus based NLP also was been introduced or was started. So corpus based NLP means now we have lots of data. Suppose we are working with a product review website, for any product we want to know whether that product is good or bad. So that kind of, already if Amazon is started means what, for each product then Amazon has a service like we can give the review to the Amazon. So in that time what it happened is, now we have for any product of in Amazon we have n number of reviews. So analysis of those reviews manually is obviously time consuming, as well as we have to have knowledge of all the comments. So what we can do in part of that, we can use a corpus, that is use all these comments to understand what is the intent of this comment, like whether the comment are positive, like good for that product is good or bad. That can be done using a machine learning algorithm. And obviously the content that is in either English or mixed language, so that is our corpus or data. From that data experts made the corpus, that is each data will be, now suppose the product is very good. So what kind of this sentence is? This sentence is a positive sentence. So this tagging was been done in the corpus. First Amazon, all the reviews will be only in the form of text, and someone or some expert will be combining this text with the gold outcomes, that is positive, negative, or etc. Similarly for every field, suppose a summary generation system, then what we will be having, for each of the text we will be having a small summary of some length, maybe 200 words, 250 words, something. So kind like that we will be creating a data set for every data. So first we will be having the raw data. From that we will be processing the raw data into a structured form, and finally we will be having a perfect we call it as a data set that will be having input output mapping. And this data set obviously used for supervised learning, because mostly used for supervised learning, because we have a input output. Also we can have some data which is only the text, only the sentences, and no one has created the summary, so it will be having only the input portions. Now in 2010, rise of deep learning and word embeddings like word2vec and globe was there, as well as same times many other deep learning systems like BGGNet, ResNet, all these have been started because of this ImageNet data set, etc. So at that same time, with the growth of deep learning or machine learning, NLP's growth also has been started. In 2020s now, we are mostly transformer based large language models. Now coming to the core concepts of NLP or different levels of NLP, the levels are like phonology level, like how humans speak and how to deal with those kind of languages, morphological language and level, and lexical level. These are the word level analysis of any text. Then semantic level and syntactic level, we have discourse analysis as well as pragmatic analysis. All this we will be discussing one by one in this lecture. And in the later videos or in the later lecture, we will be having each one as in detail. Now we will be briefly discussing about these lectures. First, what is phonology? Phonology refers to the study of sound patterns in the language and how sounds are organized or used to convey the meaning. Suppose when we talk to someone, every sound, even a word with the sound, it has a different meaning. For example, when we are talking politely, it may be a request. When we are talking loudly, then it may be a question or a command. So we have to understand each of the sound as well as sound, how this pronunciation has to be converted into word. For example, cat, we don't say cat, we say basically ka-eta, cat. So that is the phonics sound of this cat, which has been analyzed by different sound patterns in this study. So how each of the sound will be converted finally to either text or either for any input of our NLP system. So that is the study we do in this label, that is speech to text or any input, other input, that is speech to speech. If we want to convert, suppose to language, Telugu to you want to convert into English, then basically we have to understand what is the speech of Telugu and then appropriate a language in English. So that we understand in this phonology. The next concept that we need to learn in NLP is morphology. Morphology refers to the study of internal structure of words and how words are being that is the smaller meaning or meaningful words are called morphemes in each word. For example, we have a word happiness. So if we divide this word happiness, we will be having a word called happy as well as another portion of this which is ness. Or if we have a word as unhappy, then it can be divided into two parts, un as well as happy. So this how words have been formed with what are the root words that we learn in our morphemes. So you can see here morphemes have been divided into two parts, that is bound and free. So free morphemes are basically each of the real word or root word that will be having a meaningful that will be meaningful or had a meaning. For example, the real word in our portion is like noun, verbs, all the predefined words or open classes also we have. So all these words, for example, bad, good, etc., etc., all these words that are our actual words, that is free class words, that can again be subdivided into two parts. One is open class as well as closed class. This open class means that there are some classes like noun and verb which are not fixed in number. When we are talking about noun, maybe noun of a person, then anyone can give a new noun, and all these names of a person may not have the meaning or may be having meaning, or we can give any noun, anything, any name. Whenever we are coming with any name, then whatever the name you are giving, now it becomes a noun. So this noun are in open in class, that is not in fixed number. Same verb. Previously we used to have verb means eating, doing, all these things, means it means a work. Now we are having many different new verbs also. Like previously we don't had a word like chat. Now we are having a word like chatting, and this chatting is a new verb that we've been created. So now verb also became a open class, because when we are before coming to NLP in picture, or before in machine learning in this way, or before the era of the smart phones, etc., we was not having too many words. Now every day we are creating new words even. So all these verbs, adverbs, obviously, so all these portions are becoming open class. Now what is closed class? Closed class, for example, we are taking about article. Article is fixed in number, like a and the. We cannot have a new article in that one, or we cannot add a new article. So those classes of the POS tagging or part of speech which has fixed in number, like all the numbers. So for example, preposition, in, out, under, on, all these things, these are almost fixed in number, right? So these are called as closed class, means we cannot add a new member to these classes or these groups. But when we are talking about noun, we can every day add new members, or verbs or adverbs, we can add a new member. For example, I say chat is a new word now, so we can add chatting, and that is a task we are doing, so it is a new word formed. Now coming to bonded group, when we are talking about free, all these words are mostly we are talking it as a meaningful word, or has some meaning in them. In bond or bound, we don't have a most of the word will not be having a meaning. This comes into two parts. One is affix, where it is derivational. Another one is inflectational. In derivational, it has divided into two parts again, prefix and suffix. So Derivational means, suppose we are taking any word from this class. Suppose we have taken a word called happy. So when I am using any of the derivational term from here, so suppose I have used a word called now unhappy. So this unhappy, it is changing the meaning of the happy, right? Happy means I am happy. Unhappy means I am not a happy person. That is the meaning. Unhappy means what? It is sad. That is, it is changing the state of the word. That is called derivational part. Same, suppose friend. It shows two person having a friend or something. That is a state. And when we change it to friendship, then the word meaning, it changes. In inclusional meaning, the meaning of the word don't changes. It only changes the state. For example, deep, a word deep, and deeper. The word still remains the same. There is another part of bound that is called contractible. Here we are using, suppose is, are, will. Suppose we are assuming this I will, means we are using the apostrophe s like this. So this kind of representation we use here. So for example, don't. So whenever we are using this kind of words, these are called contractible words. So these are all morphemes. That is the word level study. That is how we can divide our words to the smallest part of the representation. Or suppose we have a word called it, or we can have, this is another form of the root word called eat, right? So the study of understanding from it, how we will be converting into it. So this is the study what we do in the morphology or morphological analysis part. And two part we have to learn here is, one is stemming, another one is lemmatization. These are two techniques to do this. Means for any word is given, suppose unhappy is given or any other word is given, what is the root form of this word? That we need to understand or learn. The stemming is one of the previous or starting techniques. In stemming, there are separate rules are given. For example, if a word contains ed, if a word contains an, then that will remove these words. That is, there are some predefined prefix or suffixes or in inclinational things that will be removed during the stemming part. So suppose when I have removed the word step, stepped, then in this word I have removed ed, then what is the actual word? Root. Still it is a meaningful or actual word that we are searching. So this is a correct stemming process. But at the same time, suppose a word is there, bed, and now I am removing using, because it is a rule based, it will remove all the ed from the words. So here what it will be doing, so suppose a word is there, bed, what it is basically doing, it is basically removing the ed. So the word left is only b, and b is no longer a meaningful word. So that is the disadvantage when we are using the technique called stemming. So sometimes we are using stemming still because of our need, but mostly in most of the cases we will be using now lemmatization. That is a corpus based root word finding or morphemes finding algorithm, where we basically convert each of the root based on the corpus. We teach our system to identify the root words. For example, in this one, it will not for step it will remove the word ed, that will be step. But for the bed, it will not remove the bad word like ed. It will only keep the bad word as it is. So all these things we'll be studying in the morphological analysis part. Now the next concept that we'll be learning is lexical analysis. This is again a word level analysis part that we'll be working. So what in lexical analysis we learn is, lexical analysis deals with processing text at the word level, including identifying words, removing noise, assigning basic linguistic informations. So removing noise whenever we are talking, basically in this lexical analysis part, we identify each of the lexicons. For example, if we talk about the structured language, C language, so suppose int I or int any name, and so for this portion we know that we have three lexicons. Int is itself a lexicon, I can be identify a name, and this is a ending statement. So like that, here also, like in natural language also, we have to extract the meaningful word for any like sentences or any number of like any paragraph or any word document. From here we'll be extracting each of the meaningful word in certain way, so that the word remaining, it will be remaining the, like it will carry the same meaning. For example, in this structure we know that if has to come together, so it will be forming a correct word. Then one brace, this is the opening statement we know. Then x greater than and 3.5, 3, whenever we are writing 3 point, so basically it is understanding that it is a numerical value, and there is nothing called 3 point. 3 point has to have a number at the end, right? So 3.1 has to be coming, like it has to come together. So all this understanding of the numbers, like normally whenever we are putting an end dot in any end of the sentence, that means that it is the end of the sentence, that is end limited. But here whenever we are working with the numerical values, 3 point, it means that it has a decimal value at the end. So these, all these things, whenever we are writing something, that has to be understood or analyzed during the lexical analysis part. It involves in this portion, it involves basically the tokenization, that is identifying each of the token or each of the sentences. So one popular tokenization technique that we use basically is word level tokenizer. That is, in English, suppose we are talking, each of the word will be divided based on the space portions in between the words. So that is the tokenization. Then we will be removing stop words. Stop word means based on your corpus or task, the unwanted words that you don't need in your text, that will be removed. For example, in C language also, whenever we are talking about print statement, inside this brace, whatever you can write, right, would like it will not give any syntax error. And same thing, we can be like, this portion can be ignored also during the compiler phases. So that is stop word removal. And finally we'll be normalizing like the text, and we'll prepare each of the word for our next level. So up to this level, that is morphological analysis, phonics or lexical analysis, all this works as a word level. After that, once we are worked with the word level, that is, we have understood how our words are or how our word need to be formed. After that, the next level, we start with the sentence, like a syntax or semantics, that basically has a length of like maybe a sentence or a paragraph, how it is giving. So in syntax and semantics, we work with the sentences and we understand whether a sentence is correctly formed or not. For example, in English, we have a grammar rules, right? We have certain grammar rules based on which we can decide our like sentence is correct, grammatically correct or not. For example, we cannot mix past and present tense together in a sentence, or we cannot mix like a question mark as well as simpler sentence. So there are several rules or grammatical structures we have that we need to check for our sentences as well as in like NLP, natural language processing task. So because we are working with any of the natural languages, it may be English, Hindi, etc. So we, for each of these languages, we have different types of structures. For example, in English, it may be, the structure may be noun, verb, adverb, or in Hindi it may be different structures. So like subject, object, verb, in some lecture you will be seeing, in some of the languages you will be seeing the agreements are like subject, object and verb. In some of the thing you will be seeing subject, object and verb, subject, verb and object, like in most of the English sentences. So this analyzes how our sentences should be as well as how it is that we are learning, we check in our syntactic analysis. Suppose we are converting a sentence from English to Hindi, then the verb that is placed in English sentences is not same in the same place of the Hindi sentences. That we need to understand and act accordingly. Suppose even in Hindi, suppose and English, suppose the word you. In English, you means we refer to everyone, either it is smaller than you or bigger than you, any person. But when we convert the same text to Hindi, then if it is a older person than you, then you supposed to, or respected person, then you supposed to replace that you by up. Same equal person means tum, or smaller than you means tu. So this kind of language understanding we need to do, and all these things are being done in the syntax analysis or parsing. Now, what is parsing? From these words, we basically, from these sentences, we convert each of the word. First, we analyze the lexical part, and then we understand the POS tagging. That is part of sentence tagging we do for each of the sentences. For example, noun will be given a noun tag, verb will be given as VV tag, or different types of verb tag. And finally, we have to form a tree-like structure, and that will be analyzed using our compiler or other structure, so that our sentences is grammatically correct or not. That will be checked in these phases. For example, you can see here, subject is divided into two phases that we basically call as NP-VP, that is noun phase and verb phase. And this noun phase can have again noun, verb or adverb, anything it can have. But here in this sentence particularly, term 8. So you can know that 8 is a part of verb. So it will directly go under the verb phase. So remaining all are coming under verb phase. So term is in the noun phase. So term, from noun phase we have only one noun now, and that is term 8. So in the verb phase we have verb, noun and prepositional phase, and it has been further divided into based on our post tags. Even you can divide a same sentence into multiple phase trees. Suppose I am dividing this to another phase trees like term 8, that is S tends to NP, VP, and this NP is again divided into NP and VP. Like that also you can do. Like here NP will be N, and finally it will be term, and here we'll be working with the VP. But mostly the correct form is that whenever a verb phrase will be having, it will have some set of rules. For example, verb phrase always starts with a verb. So from a sentence we need to identify where is the main verb is locating. So from that we can continue as a verb phrase. Now even a sentence can start with directly the verb phrase. It may not be having a noun phrase. Suppose we're saying someone eat the food, then eat itself is a verb, right? In this phrase we will not be having a noun, but that is also a valid statement. Some of the sentences in English starts with WH word, like what are you doing, etc. So that is not directly starting with a noun, that is starting with the phrases like what, right? So WH words. So each of these are already predefined, that is different types of sentences we have in our grammars that we have studied, and same things now we have to implement, or we have to teach our machine to understand as well as to work. So these things like grammatically a sentence is correct or not, or how to understand our machine, or how to teach our machine to work with this, that we will teach in this phase, that is syntax and parsing. In the next phase, we are working with the meaningfulness of a sentence. For example, semantics and meaning. For example, if we are taking in a C language, so there are different kinds of errors, right? In C language, we have a error called as compiler error. Compiler error means all the syntax error. If your sentence is having any syntax kind of error, suppose you have written int float. So float is a keyword, right? So it will get an error. Like after int, you cannot directly write a float. You have to give an identifier name that is correct name. So that cannot be again a keyword. So this is a kind of error. Suppose every sentence has to end with a semicolon. Somewhere you have started opening braces, you have missed that one. So all these kind of things that has been defined in the syntax of C programming. So these errors will be identified in the phase called as syntax error or parsing. In this portion, we will be identifying these errors. But there are some other errors that is like not written. There is no written rules, but we still have those kind of errors. For example, any interrupt error, or we have this kind of like divided by 0. So all these are like whenever we are now runtime errors. So this is, you can somehow assume as a semantic errors, but though they are not correctly like this, but some of the errors you can assume as a semantic errors. Now from this one you may be identified at least what is the meaning of syntax. So syntax means the predefined rules that has been already defined. Now then, what is semantics or semantics of a sentence? There will be certain words or certain things which are directly not the same, but then also we assume those things are similar. So for example, I said who is the Prime Minister of India? So we'll not be having a India, then we directly know that it will be Narendra Modi. So how we'll be defining this one? How this answer we got? These are not meaning like syntactically or in a meaningful way. Prime Minister should not be Narendra Modi, right? If we talk about English sentences, but semantically we know that the answer has to be Narendra Modi. So this thing we learn in semantics or meanings. In semantics, basically we check with the different synonyms or meaningfulness of the word. One of the popular measures of semantics is WMD, that is called word mover distance. So in semantics, semantic deals with the meaning of word or the sentences. Understanding semantic is crucial tasks such as question answering and sentiment analysis. Now, for example, taking the sentences of if we take this task, that is sentiment analysis, we have to understand from the n number of sentences whether, for example, a product, whether that product is good or bad, that is positive or negative. We are identifying from the group of sentences. So suppose there is some word like good, better, or it is best, or it is damn good. Such words, somehow we have to convert all this word to good. That means what? All the relatively meaningful words or similar words we are converting here to good, or we are having representing as a word good. So how to do this? Though this good or better, they don't have the same meaning, but they are similar. So all these things we need to understand, and machine understands through this analysis part, that is called semantic analysis part. So for example, one of the important tasks in many of the NLP, that is analysis or evaluation portion, that is comparing two output. Now when we are talking about several outputs in NLP, one of the crucial part is to evaluate your system. For example, summary generation. Then whoever has generated the summary, or whoever is working with the generation of summary, their perspectives or point of view may be different, and same way it reflects in the output of the document. For example, if we are talking about any math data, so we know that 3 plus 2 or 2 plus 3, it will be always 5. We cannot change this output. So this is my input, 2 plus 3. Our output is fixed, and that is correct, 100% correct, we can say. But suppose now I am creating a data set, and I am creating a summarization data set. So I have taken a text data like a news article, and I have went through it nicely, maybe several times, and I have created a summary of that, or I have used a chat GPT to create a summary of that. Can I say that this summary is 100% correct, or it is correct for everyone? No, because everyone's way of writing, if I give the same text to generate summary for 100 people, 100 people's though meaning will be same, but the generation of summary will be changing. The way the word are being used, the way we have learned, everything will come into picture, and the summary that will be generated by these 100 people will be different. Now I have to identify how much similar with my summary generation to others. So this evaluation or this comparison we can do if we work with the semantic analysis. So because of word even writing, if I give you to write a sentence, 10 sentence about like iPhone, Apple, suppose, then all of your writing will be different, right? But the meaning, if I more specifically say, you have to write about specification, even some of the words will not be matching, but some of the words will be matching. So based on that, we can identify the semantics of the word or meaningfulness of the word, or finally how much similar these two are. So these similarities, if we work with the syntactic similarity, sometimes it gives very low accuracy, but if we go with the meaning or intent of speaking, then this is more accurate. And that's is the semantics, or how to design those things, how to take all the words like synonyms and all this we teach in semantic analysis. The next concept that we need to learn in NLP is pragmatics. Now it is totally different from semantics. For example, initially I said we are making an IoT based system, and now we want it to like understand my intent of speaking, and it should work accordingly. Suppose I say to my smart home or smart home based whatever it is, we are saying now, suppose it is too cold, then the machine has to understand that you are giving a command that you have to switch off the AC or you have to raise the temperature. How machine will understand? It is too cold nowhere means that switch off the machine or raise the temperature, right? But that is the intent. Same way we talk to our friend and our friend understands. And the same thing, or suppose I am talking to my mother and I am saying that I am not feeling hungry today, or I don't like this. What does it mean? She understands some way that I am liking for other thing, or maybe I am full or I have taken food outside. Same the thing we want now our machine to understand, like a real human person. That we basically we initially we used to start with this human computer interaction. That is the opposite end. That suppose when we are talking about Eliza and all, that time we have started this conversation, rule based conversation, like one side we are the human beings, another side it is the computer. But now in this era, what we want? Our computer to be worked or act like as well as a human. For example, we are working with Alexa and all, we or Siri, we give a command directly like it is a friend of us or someone, and we expect the same, that it has to understand our that intent, and that thing has to be learned, or like that thing has is like dealt by this portion that is called pragmatics analysis. This is much different from the semantic analysis. In semantic analysis, the like if there is 10 number of sentences, we basically compare those sentences based on somewhere the meaningfulness or somewhere the sentences has a link. In pragmatics, it is the intent of speaking. So in the last three topics, first three topics we have talked about in the word level, that is phonology, morphemes and lexical analysis. Then last three topic we have discussed in the sentence level or smaller paragraphs, that is syntax, semantics and pragmatics, having three different types of understanding or learnings. In the last portion or one more portion we have, that is called discourse analysis. Now in discourse analysis, we have to have the understanding of all those levels, because in discourse analysis it deals with the understanding of the language across multiple sentences. Till now, whatever we have worked, we have understood only the meaning of a word or only the meaning of a sentence. Now we are understanding in a whole paragraph or in a whole conversation how each of the words will be given and how to link or how to identify the sentence level analysis, as well as each of the sentences, two sentences are there, how to understand the link between these two sentences. Suppose a paragraph is given and you have to and a question answering, several questions are given. Based on this paragraph, you have to answer these questions. So suppose there is two texts. Ravi brought a laptop. The first text, he used it for programming. Now suppose a question is there, who used this for programming, or what he has used for programming. So who used it? So we know that from programming, this sentence we understood that he uses. So this he has to be linked with this term Ravi. So how to link these sentences, that we understand in the discourse analysis. Same way, what or where he did the programming, if the question is like that, where or what he did the programming, then the answer has to be laptop, right? So how it will be linking? It will be linking the word it to the laptop. You can see here, it is in the, though you can sometimes you can assume that he and Ravi, both the text are in the first place, but then it is comparing this noun to this noun. But sometimes you will be having in a sentence more than n number of nouns, or at least more than one number of nouns, like Ravi and Gita went together, and then finally it is about Gita. Then how to link this he or she to like Ravi? In English we know that he means there are several rules. It works like, first we have to identify he means it is a person, that is someone, a noun or something. Then he has to be linked with like a male person, that is called Ravi. Same in the text, if we was having a she, then it has to be, it is a female, right? Female pronoun. So we have to link with a female person. Same if there is a word called it has to be linked with either some animal. Suppose Ravi has a pet dog Tom. He gives it everyday meal. So this eat now, it is related to dog. And same way in this example, it is related to laptop. So how to link this? It is to dog or it is to laptop. That all these things we learn in this discourse analysis along with our sentence level analysis and word level analysis. And these things, this is called anaphora resolution or pronoun resolution. So this is part that we will be learning in our discourse analysis. So discourse means the identifying the different meaning across the multiple sentences when a paragraph or longer text is been given. Now once we understand this, so we need to understand now the key concepts. Or by now we have understood that a sentence will be given, of course, and we have to understand it, and we have to suppose it is a chat GPT. How your machine has to understand? You have given a text, it has to answer your text, right? So it has to answer it accordingly so that it is relevant to your text. So it has to understand each of the word, it has to understand the sentence meaning, it has to understand as well as the intent of the word. So things that we learn here is sentence segmentation, means how you will be dividing a sentence into multiple part, how we will be tokenizing the sentence, that is dividing the sentence into each of the tokens. Then stemming and lemmatization techniques, means we have identified the root word of the sentence, identify the stop words or remove of the stop word, that is we will be removing unwanted word from the sentences. So all these things up to this much, basically this works under the pre-processing part of the text. Then we will be generating the dependency parsing or pause tagging or NER, that is name and analysis. Now again there is another thing. Suppose United States, what is NER deals with is, suppose we have United States of America. Now we have and we have my name, suppose Dipanwita. So Dipanwita itself is a name. So it is a single word, we can directly name it. But when we are talking about United States of America, we cannot take this off as other tag, right? We have to give this whole thing United States of America as a one like a NER tag, right? So these things, how to identify the whole name portion, and we have to give the appropriate tag. Same, even chunking deals with the portion of the text. So all these things are the different pipelines or things we have to go, like when we are working with any NLP system or NLP based application. So first step what we are doing here is, suppose I have a statement, I love machine learning. So in the tokenizer phase or token phase, in the previous C we saw that is the first step, like after sentence segmentation, we have to go for now word level. In the word level, we will be doing like tokenization. Here we are dividing each of the text into several tokens, that is I love machine learning and the finally exclamatory mark. So we have here 5 tokens in this sentence. So this is the process of tokenization, and it breaks between the words. Now every again language is different. Suppose English language, in English language each of the token are basically divided based on the spaces. Like we write whatever we write in each word, after each word we give a space. So if we are tokenizing the English sentences, we can use this space as a tokenizer part. Then we have to do the POS tagging, that is part of speech tagging. So we have predefined tags for every languages. For example, for English we have noun, pronoun, verb, adverb, adjective, then preposition, conjunction, all these things. So according to that we have to give the appropriate tag for each of the word. Like I is a pronoun, like is a verb, to, and then read, it is a verb again, and books, that is noun. So you have to give the appropriate POS tagging to each of the word. Now, what is POS tagging or part of speech tagging? It is a tagging in the process of assigning grammatical categories such as noun, verb, and adjectives to each of the word in the sentence, thereby helping in understanding the sentence grammatical structure. So from here we probably a sentence is there that has to follow a pronoun, has to be followed by a noun, a verb, and then to verb and noun. So these are the correct like way of writing a sentence that we can understand later. Now in name entity, as I said, name entity recognition, it basically understands the noun, and this noun is in like a open class. Open class means every day we are having a new number of nouns. Even we are going to a new place, the name of the person changes. Suppose in our state we have a different kind of naming, in other states we have a different kind of naming. Same in similar way in other countries we have a different kind of naming. Even there are some words which has like it is a noun, but in different places it has been used in different kinds of a noun. For example, jaguar, it can be a car, it can be an animal, but both are noun, but it has a different context or different meaning in different places. So all this analysis, or it is a analysis of noun in different levels, that we work with the name entity and recognition, that is NER. In NER, this identifies and categorizes key entities in text, example, people, organizations, and locations, which is vital for information attraction. Because suppose we are working with question answering, then there will be many questions like who did, where it did. So all these answers are basically maybe a noun. So we have to understand that the full noun, length of the noun. Suppose if I am talking about any name, then name can have surname, then it can have first name, middle name, or last name, etc., etc., right? So the whole name or whole length of name we need to identify for proper answering of the question. We cannot only take the first name. So in this this similar cases, we have to work with the NER. So in NER, how it works, basically input sentences with name and place will be given. With NLP has to scan the names. For example, Ravi, it may be a person mostly. Infosys, we know that it is a well-known organization, or location, Bangalore. Suppose it is a location, we cannot, mostly we are using this for location term. So we'll be using a predefined set of data set to understand, or we'll be using any coding part so that we can understand the full tag for the name or etc. All the a portion that is called in, that is we learn in name entity recognition part. Now we have learned how each sentence has to be organized, or how a sentence has to be worked with. Now suppose we have to do this through a coding, and most of the NLP codings are either done by rule-based system previously. Now either it works with a machine learning or deep learning algorithm. Now how this machine learning or deep learning can be used in NLP based system? So for example, what will be the step? So suppose I am taking a summarization system. So what will be the summarization system? So in summarization dataset, basically we may be having some text and its corresponding summary. So that is a dataset we have from which our system has to learn, and whenever a new text will be given, I want to generate summary through the computer. So that is my output, and these are the inputs we are given. Suppose we have a news document, and a popular dataset for summarization is called Duck series, that is Duck maybe 2001, 2002, like that. We have several datasets. Suppose now this dataset contains several document and summaries, and now we are given any similar document, we have to generate a summary. For this purpose, what will be the steps? So this is a raw data, right? The actual data we are being given. So first step for doing any machine learning or deep learning algorithm, or even rule-based algorithm, first step is data pre-processing. So in data pre-processing, what are the things we'll be doing? So first step may be tokenization. So in tokenization, we are dividing each of the word, as we have seen, we are dividing the tokens or identifying the tokens. Next step can be different types of noise removal, or before that we will be normally lower casing the words. That is, for example, some words are with capital letter and small letter, so mostly they are having the same meaning. So we'll remove some of the capital D and small letter D. We cannot take this as two different entities. So most of the time we will be doing this into small letter, converting all the text into small letter words. So after that, this one will be removing different types of noise. One of the popular noise in text is meaningless word removal. Then we can remove if text is no way related to links, etc., etc. Maybe we don't want to give in the summary, because summary will be crisp of the whole text. So suppose in your text it contains an HTTP link, etc. That text will be removing in this phase. We will remove any unnecessary data. Even some of the text may have some emojis, etc., that we have to convert into real text, that is happy, sad. Suppose in chat, etc., we write emojis mostly nowadays. So what is the meaning of the emoji? We will be converting into proper English languages. So all these steps are being performed in the pre-processing phase, along with this stop word removal. Stop word removal means we are removing the unnecessary words. For example, the In most of the sentences, it doesn't contribute anything, though it is required to form a correct English sentence, but while pre-processing or processing of the text, it doesn't contribute much. So we can remove this word, the, a, and, like that. If it is not required, then those we will consider as a stop word and will remove, because the is one of the mostly used term in many of the sentences, and it is not contributing much. Like that, we will be removing all the words, and that is called stop word. After the pre-processing phase, we need to extract the features. Now, what is features? In most of the machine learning algorithm, it inverts its input in the form of numerical values. This data it wants as the form of numerical values. Now, how to convert your text into numerical values? So there are different methods. Suppose one of the method is we can calculate the length of the sentences. Maybe that can be a feature. Maybe TF-IDF can be a feature, that is term frequency and inverse document frequency. Like that, several features will be there, based on which we will be converting each of the sentences into some numerical values. Or suppose if still we want to keep the text as it is, then what are the other ways we can represent? That is our feature extraction, that we are identifying the important features. For machine learning especially, we need these features to be identified. After that, we have to take a model from our system. Suppose it is a unsupervised model, then we can take K-mean or some other model to classify all the sentences into different groups, so that we can take each of the sentences from this. In summarization, suppose one of the important aspect is redundancy. We don't want to take two similar sentences. Rather, what we can do, either we can mix two similar sentences, or we can choose any one which is contributing more from the two sentences, so that out of two similar sentences we can choose one, so that we can keep different sentences in our summary. So that is redundancy removal, and that can be either done in feature extraction or through other things. So in model training, there can be optimization based approaches. Or here, if we are talking about only machine learning, then there are different machine learning algorithms based on its supervised or unsupervised on nature. So that we'll discuss. So we have to select a model, we have to train the model, then finally we have to understand our output, and finally output generation. What model we'll be choosing, that depends on our data as well as the input output learning. So to understand this, we are dividing our whole machine learning algorithm, basically are divided into two parts, that is supervised and unsupervised learning. In supervised learning, we have a data set, basically that is been called as label data set, that is input and correct output. Suppose we are taking a data set, this can be my input feature. Every input feature is mapped with the output. So that supervised is like in front of it, there is a teacher who, whenever you are doing something, it is checking whether you are correctly doing or not. So obviously in supervised data set, you can map your input with the output. Even for the most of the deep learning system, we need supervised learning or data set that is labeled, so that it can learn from the data set itself, because in deep learning we are not giving any features for this. In unsupervised learning, suppose we are having many summaries or many sentences, but we don't have the goal summaries, then what we can do? From the sentences, suppose there are 10 sentences, we can divide it into multiple classes, and based on our requirement, maybe this is the highest contributing class, we can take this as summary, or we can take some of the line, removing the redundancy from this one, then some of the sentence from this, or like top 3 or less reducing, we can directly remove, and some of the depending on our need, we can divide. So when we don't have a data set that is goal data set, that we call, that is label data set, then we'll be going for unsupervised learning techniques. Whenever we are working with data that has label data, then we'll be going for supervised based techniques. So some of the application of this is like a spam or not spam email classification. So we are having a data set with some data email with here two class, maybe spam or not spam, like that. This output will contain this kind of data, that is, it is having a binary class classification. For example, sentiment analysis in the goal, if it is a goal data set, then each of the text will be having a output mapping with a positive, negative or neutral, maybe, or maybe more than number of these classes. Basically it will be positive, negative, that is binary class, or positive, negative, neutral, three class classification. If it is not a goal data set, then or if it is not a label data set, then what we'll be having? We'll be having mostly only the text, will not have this output mappings. So if we have this, then we can go for a supervised learning like algorithms. Or if we are having a image or speech recognition, that is every image is given with a appropriate naming or caption, then we can go for this supervised learning. Now coming to unsupervised learning, and as I said, this data set will be having only data, no appropriate labeling to it. So what we have to understand now, from this data set, it don't have any label, so it cannot learn automatically, right? What it can do, we can identify some pattern from the data itself, and then we can classify, or we can like give them a several class, and then we can match the data according to our name. So it is basically exploring or grouping of the data. For example, customer segmentation. Now for example, you are going to a store, every day you are buying something. So based on your bill, based on your preferences, a company want to now identify who are the most valuable customers. So what it can do, it can identify who is purchasing more item, or who is purchasing valuable item, or who is coming regularly. Like that, it can have different classes, and then according to that, it can segment its classes so that the business will be maximized. Similarly, like clustering similar documents. Suppose I want to now I want to do a research on particular topic, text summarization, but I have different types of other documents in net also, right? Suppose I'm going through Google Scholar, then it has many documents. Now suppose now I have only choose for text summarization, again it has different models, different data sets. So I can group all my data into, suppose in one group it will be rule-based system with only drug data set. In other group it can be deep learning based system. Like that, how to cluster different documents into different groups. So it will be depending on some features, some of the content of the text, and that portion can be done using the unsupervised learning. So these are the differences between supervised learning and unsupervised learning. And unsupervised learning uses the label data in supervised learning, and unsupervised learning we mostly work with the unlabeled data, where we use the patterns etc. to classify to cluster our documents. The another part of machine learning or the deep learning, where we are more now in this era, we have more and more data sets. So basically in deep learning, what we want, we don't want now to give the features to our model. What we want, rather in the deep learning model, these are highly accurate, or we can say that it can learn automatically from the data. So what we can do, we want our system to automatically learn the feature. We don't want to give the feature, we directly give the sentences as well as the mapping, so that it can create its own learning, or it can learn from the data, and it can give an appropriate result, or a word embedding, like how words are there etc. Like a deep learning, where we have when more data or more advanced architectures, so the system will be now automatically learning. For that, what we basically need is a data set with correct mapping, or a perfect data set for this one, and we have to choose the perfect model for deep learning based architectures. Now coming to NLP libraries, the popular NLP libraries are NLTK, that is open source, and you can directly use this. This is the logo of the NLTK site. So features like pre-processing features, mostly like tokenization, stop word removal, stemming, lemmatization, pause tagging, parsing and syntax analysis, even NIR, all these things are already inbuilt, or codings are already there in NLTK. Many popular lectures are there for NLTK as well as SPACY. So you can directly go and check these sites to learn at least the pre-processing step for NLP based any of the topics. Then now, as we are moving towards more towards the transformers, you can have this Hugging based transformers, where we have different GPT versions like BART etc. Bidirectional transformer model etc. T5 text to text transformer model, that is mostly used for like summarization etc. So large text etc. So all these tasks can be like, we can start with the Hugging Face transformers models, and then we can modify our models according to our requirement, or we can do more research on these topics. And most of the tasks that can be done here is text classification, sentiment analysis, NAR, question answering, and text generation or summarization task. So these are some popular tools that we can directly use, that because it has in variant libraries, many resources already been available there. Now coming to application, and throughout the lecture I already has been discussed like chatbots or virtual assistants. Nowadays we are using mostly chat GPTs, as this is an era we call as chat GPT, which has been made in the backbone of NLP. So now more researches are, obviously the maximum research are been done in the language, like that is English language, because all the resources or it is has more familiarity. But like in country like India, what we want now is, suppose most of the population don't understand the English language, so what they want basically a chatbot in your own language. To develop that one, as we have to do all these things starting from the word level, then sentence level or root level. Use this chatbot, or to make this chatbot and virtual assistant, these are the popular application of NLP. The other applications are like text summarization, like we want to generate an automatic summary system, so which will be working for summarization part. So here also we need the knowledge of NLP. Another application of NLP is translation system. Suppose you want to convert any speech to text or text to text, like we want to convert a Telugu to English text or vice versa, so we can use this. So finally I am concluding the introduction part of this series. So we have learned here different techniques of NLP, or we have learned different phases of NLP, which will be learning in more details, or different applications of NLP. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.